We started to talk about TCP flow control and reliability. So, as we said before, TCP uses the window field in the TCP header so that each client and server, each one will report to the other one, because we said that TCP is bidirectional. So each one will report to the other the amount of bytes or the amount of data that it can receive in its buffer. So, for example, during the connection establishment, when you respond back to the sync request, you have to report the window size, and also the client, when it sends back, it has to report its own window size. So that when the client sends, the client will send the window size, and the server will send its own window size. Because, as we said, TCP is full duplex, which means that sending and receiving happens at the same time. The window size will then be used for flow control, and we'll see how it is used for flow control in a minute. So the TCP receive window size is the amount of the received data in bytes. Okay, so it's not like 1, 2, 3. No, it's the amount in bytes. So this is the amount or the number of bytes I can receive in my buffer now. And as we said, that this is dependent pretty much on how the application on the other side consumes this data from the buffer. So the faster the application consuming this data from the buffer, the more the buffer will get empty, in which case this window size will be larger. The client, so these are examples. So the client window size could be like 5,000 bytes, in which case the server is allowed to send the client up to 5,000 bytes only, not 5,000 segments, 5,000 bytes. So these 5,000 bytes could be sent in 3 segments, 4 segments, whatever. So, when you receive a segment, you always have to update this window size. So if you find that in the receiving segment that the window size is 0, for example, then you have to stop. I cannot receive any more bytes from you. So in that case, you have to stop sending anything until you get an acknowledgement that the window size is increasing back to positive number.
Doctor, how the window size is specified?
How the window size is specified? It depends on the buffer allocated to that socket on each side. Because you have a socket. A socket is just a buffer, as we said before. So this buffer has a length. Okay? So the buffer is divided into 2 parts. One part which is full of data which are waiting to be processed by the application, in which case they are waiting in the line. There is another part of the buffer which is empty. So the part of the buffer that's empty, this is what you have to report back.
So this is the window size?
Yes, this is the window size, yes. This is the window size. You have to report back to the other side. So the other side cannot send you more bytes than what you can handle at this point in time. Okay, so and then for each segment you have to always report your available window size. Available window size here is the available unused buffer size on each side. Okay. So for example, this is an example that shows an application. The application is trying to send a file of, let's say, like 5,000 bytes or more. Okay, it's continuing. But these 5,000 or more bytes are divided into 1,000 each segment. So the first segment will have from byte 1 to byte 1,000, and then from 1,001 to 2,000, and so on. So these are now the segments. TCP will take each segment and then will add the TCP header. So now what we need to know is that what is the value of the TCP header that allows us to provide this flow control. So when TCP has a large file size, it divides it into chunks. Each chunk will have a TCP header, which shows, for example, the sequence number will have to be updated each time. The sequence number will have the first byte in that segment. So we'll see how. The size of the chunk is known to be the maximum segment size, and this maximum segment size is something that's fixed. Okay, and it depends on some factors which we will discuss later. Okay, but it's fixed number. Then the data that is coming from the application will be divided based on this maximum segment size. If it's 1,000, you'll divide it into 1,000 segments. And this is one of the things, the maximum segment size, this is one of the things that sometimes gets communicated through the TCP options. Okay, we said that the TCP options is a variable field which can take any length from 0 to 40. Okay, so that's one of the things that can be communicated through the options field. So we will talk about an example where the web server uses some segments with the maximum segment size of 1,000, whereas the client uses a window size of 5,000. Window size, huh? This is the maximum segment size, and this is that window size, which means that for this example, we have 1,000, 1,000 as segment size, and then the client has a window size, available window size of 5,000.
So can accept 5 segments?
Can accept up to 5 segments. Can accept up to 5 segments without having to wait for the application to process any of them. Because as you receive more and more segments in the buffer, of course the application can consume some of these segments, in which case the buffer will get empty again. So the idea is that it's a real-time communication, right? So as you fill the buffer, the application is consuming some of them, it makes the buffer empty again. So that's how it works. The sequence number starts with, let's say, 1 to indicate that I'm starting from, again, as we said, we don't have to start with 1. The initial sequence number could be like 100, in which case we'll start with 100 and the next one will be 1,100. So it's okay. But here this example talks about a start sequence number of 1. Okay? So the first segment will start with sequence number of 1, and then the client can then reply back by saying, I acknowledge, okay? But there is some possibility, and we'll talk about that as one of the variations of TCP. You can send other segments without having to wait for the acknowledgement. So that's also possible, and we'll talk about the pros and cons of each one. So assuming that the server will keep sending, okay, so the server can send 1, 2, 3, 4, 5, but then it has to wait. When it waits, then, as we said, the acknowledgement number will be the acknowledgement number will indicate that I have received up to 5,000 bytes correctly. Please send me 5,001, right? So this is what we agreed on last time. And then it will send the window size. How come the window size here has become 5,000 even though I have sent 5 segments already? This indicates that even though you have sent me five segments, the application was able to consume all of them, right? So it's possible that this 5,000 will remain the same, which indicates that, okay, the application has consumed all of them. You can send me another 5, no problem. Or this could be like 3,000, or it could be 2,000, or it could be 0. You send me 5 segments and the application did not consume any of them. So it depends. So this number has to be communicated all the time. Okay? But then here the server will send 5 segments because the last information was during the connection establishment. It knew that the client can accept up to 5,000. So it sent 5,000 and then it has to wait. Because the last information was the window size was 5,000. So I know that I can send you 5,000 bytes without having to wait. Okay, and this is the most efficient way. So send 1, 2, 3, 4, 5. But then after 5, I know that the window size was 5,000, so I have to wait. When I receive the acknowledgement luckily has a window size of 5,000 again, which means that, okay, I can start again and I can send you another 5,000 and so on. Okay? So of course, that's what's described here. The sending host cannot send any data past the send window. That's why it has to wait after sending five segments. And the acknowledgement will indicate that that I received up to 5,000. Okay, so please send me 5,001. And then the large window size received, which is the maximum, which is 5,000, indicates that, okay, you can start from scratch. You can send me another five segments again. Something new here. So in that case, when the client window sends when the client sends the window size here as 5,000, as we said, so the server will send 1, 2, 3, 4, 5, and then it waits. When it receives the acknowledgement here acknowledges all these 5 segments all at once. The acknowledgement is always accumulative, which means that when I receive an acknowledgement, depending on this number here, this number tells me what you have received so far, okay, and what you are waiting for. So if this, for example, is 3001, then I know for sure that you have received up to 3,000 bytes, okay, and you're waiting for 3001. If I sent it, then I know that, okay, so you did not receive the 4th and the 5th segment. You still did not receive them. At least you did not acknowledge that you received them. So in that case, I have to look at the window size here to know what is the maximum number of bytes I have to send you. So if it's 5,000, then in that case I should send you another 3 segments and wait. Okay? So that's how it goes. So always read the acknowledgement. You know exactly what you have delivered correctly on the other side. From the acknowledgement number, you know this information. From the window size, you know that starting from the next one, how many more segments you can send. Now, this example is synchronized perfectly, but live is much more complicated, of course. But this is just to show you the concept. So this concept is what we call stop and wait, which means that when I know the window size, I can send you 5 segments and then I stop. Okay? And then I have to wait for the acknowledgement. And the acknowledgement will tell me, okay, you have received all of them correctly. Then I send another 5 segments and then stop. That's why it's called stop and wait. Okay? So if you send me here 3,000, I will send you 3 segments and then stop. If you send me 5, I will send you 3 and then stop. If you send me 10,000, then I send you 10 segments and then stop. So you always have to send all the 10 segments and then wait for an acknowledgement. Okay?
Doctor, but you said the size here is 10, but you can see that it's only 5 sequence.
No, the size of what? This is the size of the server window. Remember, this means that the client is allowed to send up to 10 segments, but the client is not sending any. Here, this example does not show that the client is sending anything. But this 10,000 here is for the client to know how many segments it has to, or it can send before it waits for acknowledgement. What we care about here is this 5,000. The 5,000 is coming from the client to the server to indicate to the server that you can send me up to 5 segments. Okay? So, and again, stop and wait here. You send the 5 segments and then wait. Now the question is, what is the disadvantage in this stop and wait technique? Okay, it's easy, it's logical. You report to me that you need 5,000, I give you 5,000. But then you have to wait, I have to wait for your acknowledgement. The problem here is that because the stop and wait allows all the transmission to happen, and then you have to wait, you always have to have like some silent periods here. You see, this time might be large, okay? That's created because of the fact that here the receiver has to wait to receive all of them before it sends an acknowledgement. So all this time here, the server on the other side is waiting for the acknowledgement, and it cannot send any more segments before it receives the acknowledgement. So that creates some silence periods here, as you can see. What is the problem with these silence periods? You're not utilizing the session. So you have a session, and you're not sending any data for this. So that actually delays the transmission of the data. I would love to have the client sending me here some early acknowledgement. If that's the case, then I can continue, right? So if the client sends me some acknowledgement early, okay, so I will update the available number of segments here, and I will keep sending. So I will not have this silence periods, because sometimes these silence periods creates some low utilization of the session.
But doctor, how can one out of the clients send early acknowledgement?
Why not? What is stopping the client from sending an acknowledgement here, for example?
Okay, but then at the end he has to wait for the 5 to send.
No, why? No, that's what we're saying, is that just the fact that the window size is 5,000, it doesn't mean that the receiver has to wait for all the 5 segments to come before it sends acknowledgement. If the receiver sends here some acknowledgements, then that's fine. That's also fine. Of course, the acknowledgement will have a 2001. The acknowledgement number will be 2001 or 3001. This indicates that the receiver has received successfully up to 2,000 bytes or 3,000 bytes, okay, and it's waiting for 3001. If I receive that, then I will say, okay, I can send 1, 2, and then I will send 3 without having to wait. I will show you this on the timeline. I will show you this. I'm just trying to motivate the fact that these wait periods can somehow be eliminated or reduced. Okay, and I would be happy if I do that, because then I can increase the utilization of the session. Otherwise, I will keep the connection open for a long time, but the actual utilization is actually small part.
But it's the same. You know what?
No, I will show you. It's not the same.
Okay.
Any questions?
I
Okay.
will wait.
Okay. Yeah, stop and wait. Okay. So the TCP window size. So that's the same continuation. Nothing is new here. If too much data is being sent, acceptable window size is reduced. So if the receiver receives too many segments, for example, which is very unlikely for the case of stop and wait, by the way. For stop and wait, chances are you will not receive too many segments all at once, because these silence periods will create some kind of a smooth delays and stuff, which is in a way an advantage. But the problem is that I would love to reduce these wait times so that the utilization of the session end to end will be more. Because at the end of the day, I like to deliver my file in the fastest way possible, right? So this will reflect on the user experience. If I have this wait, imagine if this wait time is like, let's say, 2 seconds, 3 seconds. So during 2 seconds or 3 seconds, I'm not utilizing the channel in any way. I'm not utilizing the session. So imagine if you have to do that every 10 seconds, you have 2 seconds, you have to wait. Then your utilization is only 80% or less, or maybe 70%. Whereas you would like it to be 100% or 95%, so that you can deliver the file in the fastest way possible. So,
This in the situation we can send and receive at the same time.
right, yes, that's what we said, yes.
So that's why we can do it the way.
Yes, yeah. So this acknowledgement can be actually a segment coming from the client to the server. As we said before, the client can actually acknowledge and send one segment from its side to the server at the same time. So you can have one segment and then set the acknowledgement flag to 1 to indicate that this is a new segment that I'm trying to send you. And by the way, the acknowledgement is in this segment, that I have received some of your segments correctly. So we can actually, since it's bidirectional, we can actually facilitate sending the segments earlier. In fact, it happens anyway that you have to send segments earlier. So you might as well use it as an acknowledgement. Why not? Then there's no overhead. In fact, this will enhance the utilization, because if the client keeps sending frequent acknowledgement, this will, as we will see now, this will help the server get rid of this or eliminate this silence periods. We'll see now how this will work. So the motivation now is that we would like our session utilization to be at the maximum, right? So we want to get rid of these silence periods. And the way to do that is by using what we call sliding window technique. Sliding window technique. So the sender will maintain this sliding window. The sender. Actually, both of them are senders, by the way. So whenever we have two entities, both of them are senders. So you are sending and you are receiving at the same time, because it's bidirectional and full duplex. So in brief, each one of them will keep a sliding window, will maintain this sliding window. So the sliding window is a virtual or logical window in the transmission buffer. So you have the transmission buffer. So that you have a transmission buffer. Any socket will be composed of two buffers. One is the receiving buffer and sending buffer. Okay. So this sending buffer is what we talk about now. So we have to divide this sending buffer into 3 parts. Okay. So this is what we talk about here. So these 3 parts are. The first, the usable window of send packets, which means that these packets or these segments I have sent and I have received the acknowledgement already for these packets, which means that I'm done completely with these. So these are green. I'm done. So I don't have to do anything about them. I'm just waiting for the buffer to clear up, and that's it. So I don't have to do anything specific about these. So these yellow ones, these are octets. By octets we mean bytes. These are bytes sent, but I did not receive the acknowledgement for them until now. Okay? So in that case, the sliding window virtually, this is a virtual thing. It's like we have a logical sliding window here. The sliding window will start at the beginning of the bytes that have been sent, but I did not receive an acknowledgement for. Okay? All the bytes in this sliding window are allowed to be sent. Okay? So I will keep sending one by one. And then here, so the pointer of transmission is now here, which means that these are bytes that I can send, but I did not yet send. Okay? So I did not start to send to the server yet. And of course I did not receive acknowledgements for, because I did not send. Right? So the difference between the yellow part and the and the red part is that these, the sender has already sent them, but I did not receive an acknowledgement for. These, I have neither sent them nor received an acknowledgement for. Okay? And these ones, I have to get away from my mind because these are processed. I already sent them and I already received the acknowledgement, so I forget about them completely. Okay? So this is the part that we need to keep inside the sliding window. And of course, there is a fourth part, if you want to make it more complicated. These are bytes that I cannot send at this point. These are still in the buffer, but I cannot send. Unless I receive some acknowledgement for some of the bytes that I have already sent. Okay? And what happens is that whenever you receive some acknowledgement, you just slide the window, that's what's called sliding window. So you logically, and you do that in programming, when you program by using pointers. Are you pointers?
Yeah.
Pointers, you just increment the pointer by the amount of bytes that you have received the acknowledgement for. And this represents the fact that you have slid the window a little bit to the right. So in that case, some of these bytes will get inside the window, which means that now you can send. That's the way it works. Go ahead.
So why would I have a data that I can send?
Yeah, because remember the file itself is large, and you cannot have a sliding window that's the size of this window equals to the size of the entire file that you want to send, right? So this is a smaller window, and it's just, like you have a microscope and you're scanning through the file like this, okay? So there is a part now that you can process and send. Part of this you send, but you're still waiting for the acknowledgement. Once you receive the acknowledgement, then you can slide a little bit. But the file is large. Okay, we're talking about like few megabytes of file. So there must be some other bytes which are still waiting to be transmitted, but I cannot transmit unless I slide the window. Okay. So that's how the sliding window technique works. So we divide the buffer into 3. In fact, actually not 3, 4. If you want to make it complete. Then we have 4 parts. 2 of them are inside the window, okay, and 2 are outside the window. What we can send now are any bytes inside the window. Some of them I have already sent, and some of them I'm waiting to send. Once I receive any acknowledgement, I slide the window a little bit. Okay, so let's see how this technique can facilitate the removal of the reduction of the silence periods. So that's a graphical explanation for this. So the window size is 6, which means that just assuming that we can send 1 byte at a time. Yeah. This example talks about that. So the window size is 6, which means that I can have 6 bytes. So I start to send the bytes one by one. So what I can send is actually 6 bytes. So I sent 1, 2, 3, okay? And now I have received an acknowledgement. So the 2 colors here are different to indicate that these are bytes I have sent already, and these bytes are waiting to be sent. I can send, okay? After sending 3 bytes, I received an acknowledgement. Now I have to read the acknowledgement number, okay? And slide the window based on this acknowledgement number. This is very important. Okay? Just the fact that I sent 3 bytes, it doesn't mean that the receiver has received all the 3 bytes. In this example, yes, it did receive all the 3 bytes because the acknowledgement number is 4. But that's not a general case. The acknowledgement number could be 3. In which case, I will slide on the 3. Okay? So for this particular example, I will slide and start at 4. because all the 3 bytes have been received successfully. But if this acknowledgement number was 3, then I will slide only 2 locations. And I will begin at 3. If this acknowledgement number is 2, then I will slide only 1 location to start at 2, and so on. Any confusion? Okay? So that's the example. So this is a continuation of that example. So when I slide now, the window will be here. This is the new window now, starting from 4 all the way to 9. This is the new window location now. All these 3 have been received, and I can send 4, 5. 4 and 5 I have already sent, and 6, 7, 8, 9 are waiting to be sent. Okay? And then it happens that, again, it's up to the receiver to send me an acknowledgement whenever it wants. Okay? So the receiver will then send me an acknowledgement. Now I have to read the acknowledgement. So this acknowledgement number will indicate that you slide the window up to the location of that acknowledgement number. So now the new location will start at 6. Okay, which means that all these 5 have been received correctly. And I keep doing that. So in that case, I don't have to wait. I don't have to wait for anything.
No,
So by the time I send something, he will send me an acknowledgement back, which means I can send more. And we keep doing this bi-directional, and then we don't have to wait. I will show you that on the timeline. So that's how it goes. So as you can see now, no silence periods. So here the window size is again 5,000, as it was before. So I sent 1 and 2, and then the receiver sent me an acknowledgement with acknowledgement 2001, which indicates that all the 2,000 bytes have been received correctly. Here I can send 3 more because the window size was 5,000. Okay, and while sending these 3 more, I have received an acknowledgement that tells me that, okay, I received 2. Okay, so I will slide the window and I can send 2 more. So hopefully by sending those 2 more, I will receive another acknowledgement number which tells me 6 segments have been received correctly. Since I slide 2 already, which means now I can send up to 7. Okay, so 6 of them received correctly. Then I don't have to wait. I slide the window and I keep sending. So this way, we eliminate all the silence periods completely. We don't have to incur or to go through the overhead of waiting for silence periods with no reason. And we keep the utilization of the channel to the maximum, hopefully. Yeah. Okay, which is much faster. So any question about that? Okay, so now, so we talked about flow control, but we talked about flow control in the happy path, which means that everything reaches correctly. But we also talked about the fact that TCP provides reliability, right? Reliability means that if one segment is lost, I need to retransmit that segment. So that particular scenario talks about the fact that the sliding window technique can be combined with the reliability technique. Okay, so let's see how. So what happens is that TCP for the server, it will send the segment. The segment has a sequence number of 92, okay? And it has 8 bytes of data, which means that it starts from 92 all the way to 99, okay? For stop and wait, assuming that we were using stop and wait, I will send whether it's one segment or multiple segments, and then I have to wait for the acknowledgement. the acknowledgement has not been reached. That the acknowledgement has been lost on the way. First of all, the question is how this gets lost. We talked about this. We talked about many possibilities. We talked about the fact that this data is actually an analog signal. It gets transformed into an analog signal. If it's wireless, the wireless may actually lose it because you have noise. Router is down. Anything happens, you know. So the acknowledgement is lost. Okay. So now, if I use a stop and wait, how long do I have to wait? Okay, so the acknowledgement is lost, and I can wait up to a certain time. This time we call it a timeout. We call it the timeout. This timeout, it gets calculated inside TCP. There is some estimation technique that you use to calculate the timeout. In fact, this is a varying parameter. It's not fixed. But luckily, we don't have to go through the calculations, which is good news for you, because the calculation is rather complicated. Okay? So this timeout is a parameter inside TCP. After this timeout is elapsed, then I declare that this segment has been lost, even if the acknowledgement has been lost. Right. To me, whether the segment is lost or the acknowledgement is lost, it's the same. For me, it's the same. Right? So I will declare this segment as lost segment, in which case I will, after the timeout is elapsed, I will send the same segment again. So this is retransmission. Same sequence number, same number of bytes. What will happen here? What will happen here? The receiver will receive the segment, but the segment was received. Okay? So the receiver in that case, or the client in that case, will ignore the second one. How does it know that this is duplicate? From the sequence number. So that's easy, right? But then it's a sign for the client that the sender has not received the acknowledgement. So I will send it again. So hopefully in the next time it will arrive correctly. Okay, so that's how it goes. So if the segment is lost or the acknowledgement is lost, to me they are the same. And then I have to do retransmission. The client, if it's ever received a duplicate segment, that's perfectly fine, no problem. I will ignore it. I will discard it. Okay? But this is a sign to me that I have to send the acknowledgement again. And I will do that. And hopefully in the next time. And guess what? If this one is lost, I will have to do it again. If this one is lost, I have to do it. And I will keep that forever. And that might be one of the problems of TCP. Reliability has to be 100%. But some applications, they require that. Because imagine if you are sending a zip file. If you lose one byte, the whole file is lost. خلاص. I cannot recover the file. If one byte is lost, it's done. But for video, that's fine. If you lose one segment, you lose one or two pixels on the screen, big deal. Not a big problem. So depending on the application, TCP might be the good choice or the best choice, or it might be the worst choice. And that's why we have other protocols like UDP and others, which we will not study as part of this course, but we have tons of other transport layer protocols. So any questions? So quickly, this example talks about an immature timeout. There's nothing lost here. Nothing is lost. This scenario is very interesting because this indicates that I sent the first segment and the client sent the acknowledgement, but here I have an incorrect estimation of the timeout. Okay? So I timed out early, before the acknowledgement comes. What is the decision that I will take? The segment was lost. The server will take an incorrect decision that the acknowledgement or the segment has been lost to me, I have to retransmit the packets. And because I did not receive the acknowledgement even for the first one, remember, I have to send both of them. Because I did not receive even the acknowledgement for the first one. Right? So I timed out. When I time out, I have to go at the last segment that was acknowledged. And the last segment that was acknowledged is one that's not in this example. It's here. Which means that I will start from this one. Again. Because this one was not acknowledged. So I will send the first one again. And then I have to send the next one if I'm allowed to do that. Because the next one I did not receive the acknowledgement for again. Okay? And then, if I keep using that timeout, I will lose a lot. Why? Because, again, I timed out immaturely or prematurely. In that case, I will have to send again. So that's why this example tries to say that the estimation of the timeout is a very important factor in TCP. Because if it's done prematurely, then you will have to do several retransmissions which you shouldn't have to. And that's very dangerous. Right? And that's why there has to be a careful estimation of this timeout. So even though this example does not have anything lost, but we keep doing retransmissions unnecessarily. Okay? So this timeout is a very important parameter. Any questions?
Why did we send the second acknowledgement? We sent
That's a very interesting question. Let's see what happened here. Because there is a very interesting thing that happened here that tells us why the server did not send the next segment. Here, the sender sent the first segment, which is the first unacknowledged segment, right? Before it tries to send the second one, it received an acknowledgement. And guess what? The acknowledgement number says 120. What does this tell us? This tells us that I have actually received both. So you don't have to worry. So the acknowledgement always tells us, I received up to 119 correctly. Send me 120. So I will start from 120, which excludes this second. That's why I didn't have to send it. So that's how it worked. Okay? So we'll stop here.